Hi, now we are analyzing CSIR June 2011 Chemical Sciences. Just look at the given problems. First, just look at the 116th problem. Isotherm which has fractional coverage linearly dependent on pressure at low pressure but almost independent at high pressure is called simply Langmuir isotherm. Whenever we observe Langmuir isotherm flat where theta versus pressure at low pressures, theta, that means coverage, is directly proportional to pressure, but at high pressures theta independent of pressure. Okay, so at low pressures it is first order, at high pressures it is zero order. That means the coverage is independent of pressure. Okay, so that's why here Langmuir isotherm is the correct answer for given problem. Okay, right, now next question 115th. There are several types of mean molar masses for polymer and they are dependent on experimental methods like osmometry, light scattering, sedimentation. Correct relation between mean molar masses and experimental method is. Okay, right, now just come to the 115th question. Osmometry relates with number average molecular weight and light scattering relates with weight average and sedimentation relates with mz molecular weight. Okay, right, and next question, the unperturbed energy levels of a system or EG is equal or epsilon 0 equals 0 and epsilon 1 is equal to and epsilon 2 is equal 4. The second order correction to energy for ground state in pressure of the perturbation V, for which V10 equals 2, V20 is equal 4 and V12 equals 6 has been found to be. Okay, now just look at the 122 question answer here. Second order perturbation for nth state is expressed like this. Okay, just observe here nth state here, n is equal to nth state, and for example here perturbation for ground state, sorry, here n is the ground state, consider n is ground state, and for perturbation for ground state n is equal 0. So whenever we take n is equal 0 here, okay, right, and by just taking the sum of that means first order and second order corrections, then we can get minus 6 is the correct answer. Okay, yeah, so just check the each and every step here. Next question, an operator A is defined as A is equal to minus d by dx plus x. Which one of the following statements is true? Okay, just observe A is a Hermitian operator, A plus is an anti-Hermitian operator, both A and A plus and A plus and A are Hermitian operators. A and A plus is Hermitian, but A plus and A is anti-Hermitian. Okay, now if A adjoint is equal or adjoint of A equals to A, that is simply Hermitian operator, and adjoint of A is equal to minus A, that is anti-Hermitian operator, and we have given that A is equal to minus d by dx plus ex. Okay, just take adjoint of A and on expressions on minus d by dx, adjoint of minus d by dx plus adjoint of x. So adjoint of minus d by dx result d by dx and adjoint of x result x. Okay, right, here A is neither Hermitian nor anti-Hermitian. Just check it. A is having minus d by dx plus x, whereas adjoint of A resulting d by dx plus x. That's why A is neither Hermitian nor anti-Hermitian. Okay, now just take adjoint of A and adjoint of A. Okay, so just observe it and just taking the expressions, we can get simply adjoint of A into adjoint of A is equal to A into adjoint of A. Okay, so this simply indicating that A and adjoint of A is simply Hermitian. Okay, so whenever we observe this relation, that's simply considered as Hermitian. Okay, yeah. Next question, the rotational constant of N214 is 2 centimeter inverse. The wave number of incident radiation in a Raman spectrometer is 20487 centimeter inverse. What is the wave number of first scattered Stokes lines of N214? Right, 124th question. In Raman spectra, Stokes lines are separated by 4b and have wave number value less than incident radiation. Okay, and just remember that important point. But the first Stokes line is observed at wave number, okay, wave number of incident radiation minus 6b. Okay, here B is equal to, and so that's why 6B is equal 12 centimeter inverse. First Stokes line wave number equals to wave number of incident radiation minus 12 centimeter radiation. Okay, so here we have given the 20487 minus 12, result 20475. Okay, right. And next question 125. The virial expansion of for a real gas can be written in either of the following forms. Just observe, if BV is equal to alpha BP, the value of alpha would be, okay. So now 125th question, the virial expression for a real gas can be written as, so we have given in the given in the problem as information. From equation 2 we can write P is equal to RT by V, 1 plus BV by V plus CV by V square plus, and it goes on. Substitute this P in right hand side of equation 1. We can get PV by RT is equal to 1 plus BP RT by V into 1 plus BV by V plus CV by V square plus till 2 goes on, plus 1 plus BV by V plus CV by V plus, and it goes on. Okay, compare first term on right hand side of equation 1 and 3. We can get we can take BV is equal to BP RT. Here alpha simply indicating RT, and that is our answer. Okay, next 126th question, for a certain particle encountering a barrier, the tunneling probability is approximately exponential power minus 10. If the mass is halved and width of the barrier, that is rectangular, doubled, approximate value of the tunneling probability will be. Now just look at the 126th question. Tunneling probability equals to approximately equals to exponential power minus 2 KL, which is equal to exponential power minus 10, where K is equal to 2 ME by H cross power half and L equals to barrier length. If mass half, that is just consider M prime equals to M by 2, then K prime equals to K by under root 2, and L prime is equal to 2 L. Okay, and from that T prime is equal to exponential power minus 10 into 1 by under root 2 into 2, that simply equals to exponential power minus 10 under root 2. Okay, next 128 question, for a H2 molecule, the ground state wave function is just observe psi 1 comma 2 equals to pi 1 comma 2 and sigma 1 comma 2, where pi refers to the space part and sigma to the spin part. Given that pi 1 comma 2 equals to pi 2 comma 1, the form of sigma 1 comma 2 would be. So just look at 128 question. Just remember, this is very important, Pauli's principle. When the labels of any two identical fermions are exchanged, the total wave function changes its sign. Okay, so that is as electrons are fermions, we can take psi 1 comma 2 should be equals to minus psi 2 comma 1 and consider as equation 1. Here psi 1 comma 2 is equal to pi 1 comma 2 sigma 1 comma 2, and psi 2 comma 1 equals to pi 2 comma 1 sigma 2 comma 1, because here we have given that pi 1 comma 2 is equal to pi 2 comma 1 in the problem. Okay, to satisfy condition 1, we must have sigma 1 comma 2 is equal to minus sigma 2 comma 1 and consider as equation 2. Okay, and sigma 1 comma 2 must be equals to minus sigma 2 comma 1, and to satisfy that, sigma 1 comma 2 equals to alpha 1 beta 2 minus alpha 2 beta 1. So sigma 2 comma 1 equals to alpha 2 beta 1 minus alpha 1 beta 2, and which is equals to minus sigma 1 2. Okay, right. And next question, for an enzyme catalyzed reaction, a Lineweaver-Burke plot gave the following data. Slope is equal to 40 seconds, intercept 4 in the initial concentration of enzyme is 2.5 into 10 power minus 9 mole per decimeter cube. What is the catalytic efficiency of the reaction? Right, and now just to come to the point on 142, from enzyme kinetics, our rate is equal to K2 into initial concentration of enzyme and substrate concentration by Km plus substrate concentration, where Km is Michaelis Menten constant, and by just expanding it we can get 1 by R is equal to Km by K2 E0 into 1 by H0. So here Km by K2 E0 is slope and K by 1 by K2 E0 is intercept. Okay, by just taking the plot of it, and from that catalytic efficiency equals to K2 by Km, and which can be represented as 1 by Km by K2 into E0 by E0 concentrations, and from that 1 by slope into E0 concentration, and from that we can get 10 power 7. Okay, and next one, for an assembly of molecules molar mass equals to m at temperature T, the standard deviation of Maxwell speed is approximately. Now standard deviation in speed is taken as under root, so the expected values of v square minus v square, just observe them, and here the velocities, we indicating velocities, and one is RMS velocity, one is average velocity. So RMS velocity equals to 3 RT by m, and average velocity 8 RT by pi m, and just simplifying it we can get 0.7 under root RT by m. Okay, right, next question. If the equilibrium constant for reaction 1 and 2, just observe two reactions here are K1 and K2, the equilibrium constant for the reaction is, simply adding these two equilibrium reactions, we can get the third reaction, equilibrium reaction. For that, the equilibrium constant equals to K into T, K into K2. Okay, right, thank you very much.